Okay, so we have other things here that we've actually gone through with a lot of trial and error, but now here's a quick overview of the 3D printed parts that we have. One would be the holders, or the bracket for the pumps here, for our influent and our effluent pump. We've got this, which is our primer holder. We'll get into this right up here. So what we do here, if you want to take a sample, let's turn our agitator off for a moment. If you want to take a sample without losing the gases inside, very important here, this is an anaerobic system, so we're not leave any oxygen or gases to come or to go. So we made this airtight. We've gone over a few things here. We have a split plug design. We were not allowed to cut our probe wires, so I'll show you how this actually works. We actually made a split plug design, which is out of rubber, and as we push this in here, now we can remove the probes, add new probes, whatever we need to do. Over here, and we've got the primer sampler system that we've designed. We've also incorporated into it a float. As you can see, there are two wires into here. And as you see here, this float, you can now set this reactor to do small batches down to 1 liter, all the way up to large batches to 5 liters. Again, this is all airtight. Oxygen and gas is not going to leak past. On the other side here, we also have a sampler. So we can pull this up, and let's say you want to take a sample out right here. Let's say the bacteria is looking brown or a different color and we want to analyze it. So now we put our probe down to this level, and we have a little primer bulb that will actually suck from here, and it will bypass and pump right back into the tank. So now what we do, as you can see, the air bubble will lift up. We will slowly pump this up. As it's rising up, we've used clear tubing so we can actually see. Now that same sample would be here. We'll come around through, and now once you see your sample is ready, you can actually look at it in your bulb. If you come around to this other side, Michelle, I'll show you. So now once we have the sample ready, we open this port, we shut this bypass off, and now as we pump, you will see the syringe will fill up. Again, it'll all be clear, so we'll know exactly what we're putting into here. And so you pump the primer bulb to fill the syringe. Once you've got the sample, you close this valve to not lose the oxygen, and we can now remove this safely without disrupting the gases in here. Now we can put this onto the petri dish or whatever we need to do to analyze it. Furthermore, if we want to pull a sample and to inject it in here, again without disrupting the gases inside, you simply connect this back up, you open this valve, you open the bypass valve, and you simply press it in, and you'll see it spill right off into there. And now you close this, and it is a sealed system still. Now we've got an overview of some of the other printed parts that we've got here. Let me rotate this just slightly. One of the bigger challenges in this was to hold this diffusing ring, to hold these probes back here. Can you see that? And so that this is the piece. This is in red here. This was one of the first trial pieces. But what we've got here is, this is where our dissolved oxygen probe goes. This is where our ORP probe goes. And this is where our pH probe goes. This is where the temperature probe, which is right back here, and it came with this reactor. This will actually hold and pin it to place because this is a fixed location onto the glass, where these probes were actually being supported entirely by this piece. The center tube here will come down through, it'll come through this angle and go to our diffusing ring, as you see down here. So this will be locked in two places, one with the temperature probe, and two, we actually cut a split here so it sets into this bottom dump valve. We oversized this valve so we can dump sludge right out of the bottom here.